In lesson 11, what we want to do is we want to now take our process of completing the square and we want to start solving with it. So the opening exercise is a review of solving by inverse operations, because that's really what completing the square is. So we would start by adding the 36 to both sides here. We get 2 parentheses x minus 2 squared equals 36. We would divide both sides by 2. X minus 2 squared equals 18. We're going to square root both sides. When you square root a parenthesis, you just get what's left underneath. Now 18 is not perfect, but it does split into square root 9, square root 2. And remember, now that we've started solving, anytime you take the square root of something, you get a plus or minus out in front. So we have plus or minus 3 radical 2. We'll add the 2 to both sides. The number you move over always goes in front, the plus minus in the middle, and then in this case, the 3 square root 2 goes in the back. So that's a review from lesson 8. And now what we want to do is we want to be able to take our trinomials, complete the square, and solve with them. So if you look at x squared plus 6x minus 12 equals 0, now we want to solve. Now, we're going to show our answers in 2 ways: simplest radical form, n to the nearest hundredth. So let's take a look first. If we were just to complete the square, the first thing we would do is put our plus line and our minus line. All right, now the only thing extra here we have is our equal 0. We take the 6 divided by 2. 6 divided by 2 is 3. 3 squared is 9. So plus 9, and then since there's nothing out in front here, we don't have to worry about changing the number in the back. This parenthesis factors to x plus 3 squared. Negative 12 minus 9 is negative 21, and now we're equal to 0. So if you were just told to complete the square, you would stop right there. But if you're told to solve, now you're going to basically follow kind of our process that we did in the opening exercise of inverse operations. So we would add the 21 to both sides. X plus 3 squared equals 21. We'll square root both sides. Now, the left side's easy. 21, not a perfect square, and does not split. So in that case, it just stays plus or minus the square root of 21. We'll subtract the 3 on both sides, and we get x equals negative 3 plus or minus square root 21. That right there is called simplest radical form. So you don't have to go any further if you're told to get your exact answers or simplest radical form. However, for the nearest hundredth piece, then what we're going to do is we're going to need our calculator, and we're just going to separate this. So we're going to have negative 3 plus square root of 21 and negative 3 minus square root of 21. So we're basically just going to do that exact problem, one with a plus sign and one with a minus sign. And all we're going to do is go to our calculator. So negative 3 plus the square root of 21, that gives us 1.582. So to the nearest hundredth, we are 1.58. And then we're negative 3 minus the square root of 21, which is negative 7.58. And these would be our rounded answers. Okay, so those are the 2 different ways that they'll ask for answers. A lot of the time it's simplest radical form, but if they ask you to round, you just have to go that one additional step. So explain why factoring was not an option to solve this equation. So I'm just going to recopy it. It was x squared plus 6x minus 12. Okay, and the reason is, remember, you got to find 2 numbers that multiply to negative 12 and add to 6. And there's nothing that multiplies to negative 12 and adds to 6. Plus, whenever you get answers like this that have radicals in there, that means that factoring was definitely not an option. Okay, so if we look at number 3, solve the following equations by completing the square. Express the answers in simplest radical form. So if we look here, this has a number out in front, so we have to GCF the first two pieces. So we're x squared plus 6x plus a line, plus 5 minus our line equals 0. We divide our 6 by 2. 6 by 2 is 3. 3 squared is 9. So 9 goes on the first line. Remember, for the back here, we have to multiply. 2 times 9 is 18. So we're minus 18 in the back. 2, our parenthesis factors to x plus 3 squared. And then 5 minus 18 is negative 13. So again, if it just said to complete the square, we would stop right there. But since it wants us to solve, now we have to keep going. So add 13 to both sides. 2 parentheses x plus 3 squared equals 13. We will divide both sides by 2. X plus 3 squared equals, now you could leave it as 6.5, or I'm just going to leave it as 13 over 2. Square root both sides. Now neither of those are going to help us. They don't simplify, so we're just going to leave it exactly as it is. We'll subtract our 3, and then we'll finish with x equals negative 3 plus or minus that square root. And again, it said simplest radical form, so we can afford to stop right there. And the next one, x squared minus 2x equals 2. So we want to make sure that all of these are set equal to 0 so that our process follows as normal. So what I'd like you to do is pause the video and see if you can do completing the square and then solve this one kind of based on what we did in the last couple of examples. So there's no number in front of x squared here, so we're just going to be x squared minus 2x plus a line, and then minus 2 minus a line. So as we do that, negative 2 divided by 2 is negative 1. Negative 1 squared is a positive 1. So plus 1 on the first line, and then minus 1 on the second line. This factors into x minus 1 squared. Negative 2 minus 1 is negative 3. Now we're ready to solve. So we'll add 3, add 3. X minus 1 squared equals 3. Square root both sides. Nothing happens to the square root of 3, so it's just plus or minus square root of 3. Plus 1, and x equals 1 plus or minus the square root of 3. I want to skip ahead to number 4 because they've asked this type of question a couple times. Which of the following equations has the same solutions as x squared plus 6x minus 12 equals 0? So you don't know if it's factorable or complete the square, but once you see answer choices that look like this, whenever you have parentheses squared in your answer choices, that's usually a dead giveaway that we are completing the square. So basically what we want to do is we want to get to a certain process in our solving when one of these answer choices matches. So x squared plus 6x plus a line, and then minus 12 minus a line. 6 divided by 2 is 3. 3 squared is 9. 9, there's no number out in front, so minus 9 at the end. We are x plus 3 squared minus 21 equals 0. So we know choice 2 and choice 4 are out because they say x minus 3. So now what we're going to do is we're going to start the process of solving. Plus 21 plus 21. We get x plus 3 squared equals 21. And then there's our matching answer choice of number 1. So like you can see, it's basically just the process of completing the square, but they just don't want you to get all the way to the end. They want you to stop a little bit earlier. The next one's basically the same, so I want to jump ahead to number 6. So this is a Regents question in a little bit of a different form. A student was given the equation x squared plus 10x minus 13 equals 0 to solve by completing the square. The first step was written, or the first step that was written is shown below. So x squared plus 10x equals 13. So you can see they started by moving the number over to the other side first, and I'm going to show you how our process can match that piece. Okay. The next step in the student's process was x squared plus 10x plus c equals 13 plus c. that plus C basically represents our two lines. Now I know normally that our C is a plus and a minus, but I'm going to show you how these two are exactly the same thing. So if we followed our process here, we would look like this. So we'd put our plus line in our parentheses and our minus line outside. So we would take the 10 divided by 2. 10 divided by 2 is 5. 5 squared is 25. So we'd be 25 and 25. So what they did is they basically took both of these and they moved them to the other side. So it's basically plus a 13 and plus a 25 and plus a 13 and plus a 25. It is the same thing as what we do. It's just written in a different way. So what represents our value of C here? C is 25. All right, and it says it wants you to explain how the value of C is determined. So we found C by dividing the x coefficient by 2, then squaring that number. Okay, so it's all about taking that middle number, that coefficient in front of x, dividing it by 2, and then squaring it, and that's how we came up with our C value. So again, this problem is a little bit different than how we've been doing it, but you can see how with a little bit of tweaking, it matches up in the same way that to our process that we've been doing for the last couple lessons.